Okay, so now we need to simplify this product. Okay, so first I'm gonna just, since it's y minus x times beta hat transpose, I'm going to write that as y transpose minus beta hat transpose x transpose into y minus x times beta hat. Now, the reason I have done that is matrix laws of matrices, especially transpose of matrices, tells us that if you have xy, the product of xy transpose, it will be y transpose into x transpose, right? So that is the rule that I have used over here. And the multiplication process will be the same as you do everywhere. So y into y bar, so I get, and then y into this term, and then the second term into the first, and the second term into the second. So it's the same as normal algebra. So what I will get in that process is I'll get y transpose into y minus beta hat transpose x transpose into y minus y transpose x times beta hat, and minus into minus becomes plus beta hat transpose x transpose x beta hat. So I hope that is okay. The thing you have to remember in matrix multiplication is that x into y is not equal to y into x. So make sure that the order in which you write the element of the matrices remains consistent from left to right. Order maripoyirudhu. Now observe the middle two terms. Beta hat bar, rather beta hat transpose times x transpose times y. Now I have written over here, I have written the dimensions of these matrices. So as you can see, when you multiply, you will get a 1 cross 1 or a scalar value as beta hat transpose into x transpose into y. Similarly, the second term, that is y transpose into x into beta hat, if you notice, when you multiply it, you again get a scalar single unit value. Now, scalar values can definitely be added, which is why I can write this as, or rather E transpose E as y dash y minus 2 times beta hat transpose x transpose y plus the last term, which was beta hat transpose x transpose into x into beta hat. So now I have the expression for EI square, and if I want to minimize the error square, the deviation square, I need to use my differentiation. So simply writing it in symbols, it is partial differentiation with respect to beta of the matrix E square, EI square. So differentiating the matrix, I will get this as, 2 times x transpose y plus 2 times x transpose x times beta hat. ഇവിടെ നിങ്ങൾക്ക്, here you have to remember that when you're differentiating and you're differentiating with respect to the matrix of beta, without going into too much detail, differentiating with respect to beta and differentiating with respect to beta t has the same effect. So when you look at this, the first term does not have any beta terms, so its differentiation will be 0. The second term has one beta hat transpose, so 2 times you will get the differentiation derivative as 2 times x transpose y. Now in this third term you have something called beta hat transpose being multiplied by beta. Now according to matrix multiplication, this will be the same thing as beta hat square, because in matrix multiplication we say that x transpose into x will be something like x square. So by the same logic, this is equivalent to beta hat square times x transpose x, which is why when you differentiate it, just like x square becomes 2x, beta hat square has become 2 times x transpose x times beta hat. Okay, now if you remember, when you're trying to find the maxima or minima, your first order condition is to set the first derivative equal to 0. So you're going to put 2 times x transpose, it is minus 2 times x transpose y plus 2 times x transpose x beta hat is equal to 0. Taking the term to the right hand side so that both sides become negative, you can write this as 2 times x transpose y is equal to, or rather you can write this as 2 times x transpose x times beta hat is equal to positive 2 times x transpose y. And since 2 and 2 are scalars or numbers, they will cancel out and you have got x transpose x times beta hat is equal to x transpose y. Now pre-multiplying x transpose x on the left hand side. Pre-multiplying basically means that you are multiplying it on the left hand side. So if I pre-multiply with the inverse of x transpose x on the left hand side as well as the right hand side, so remember, when I'm pre-multiplying, that means I'm putting the term on the left hand side. So x transpose x, since I pre-multiplied on the left hand side, I'm also pre-multiplying on the right hand side. So this is how I'll write it. Now one more rule of matrix multiplication is that if you have a matrix such as A inverse into A will give you the identity matrix, which is the equivalent of 1 in form of a matrix. So x transpose x whole inverse into x transpose x becomes equal to I, and I times any matrix is equal to the same matrix. So when I is being multiplied by beta hat, I will get the term beta hat itself, and beta hat is equal to x transpose x the whole inverse times x transpose y. And this is the main formula of the estimator that you are trying to derive.